Here are the detailed answers to the review sheet for the test. Before you start, you're going to need your notes for sum and difference formulas. You're going to need your green sheet for the simplifying trig expressions, and you're going to need the double and half angle formulas. So go ahead and find those before we start. Okay, number one. They're asking you to simplify the expression. So the first thing that I notice is that there's a double angle formula, cos 2 theta. Now I'm going to change cos 2 theta, if I can, to have it in terms of cosine squared. So look on the double angle formulas. There's 3 of them for cosine of 2 theta. Find the one that has cosine in it. And the one that does is 2 cos squared theta minus 1. So instead of this, I'm going to put 2 cos squared theta minus 1. I'm going to rewrite this expression with our substitution to the right. So we have cos squared theta minus, instead of cos 2 theta, we're going to put what it's equal to, which is 2 cos squared theta minus 1. Now some of you are probably thinking, why did I put this in parentheses over here? It's really important because we're going to have to distribute out that negative to the second set of parentheses. So let's do that first. We have cos squared theta minus 2 cos squared theta plus 1 this time. Okay, what can I do? Well, I see here that these are my like terms. I have 1 cosine squared theta, and I want to take away 2 cosine squared thetas. How many am I left with? Negative 1, or negative cosine squared theta. So I simply added these by combining like terms, and then bring down the plus 1. Now, isn't that equivalent, what I just have here, the negative cosine squared theta plus 1? Isn't this the same thing as saying 1 minus cosine squared theta? And that should ring a bell. That is simply sine squared theta. So choice 1. Okay, number 2. The expression sine x minus cos x squared is equivalent to what? So what we're going to have to do here is double distribute. So let's go ahead and rewrite this twice. So we have sine x minus cos x times sine x minus cos x. So go ahead and double distribute. Sine times sine is sine squared x. Sine times negative cos is negative sine x cos x. You just write them next to each other. Negative cos x times sine x is negative sine x cos x again. I can rewrite it putting sine first. It's multiplication, so that's okay. Negative cos times negative cos is a positive cosine squared x. Now are there like terms? I have 2 of these. So I have 2 sine x cos x, but I have a negative 1 and a negative 1. So that really should be negative 2 sine x cos x. And then I have sine squared plus cosine squared left over. But that should be familiar because sine squared plus cosine squared is equal to 1. So 1 minus 2 sine x cos x. Now, unfortunately, that's not one of my answer choices. So since I know the reference sheet well, let's go back and look at it. So you should have that out next to you. And I'd like you to look at the double angle formulas. And look at sine 2a. What does sine 2a say? It says sine 2a is equal to 2 sine a cos a. Therefore, this is a double angle formula for sine 2x. So I just bring down the 1, and I have 1 minus sine 2x, choice 3. Alright, number 3. Secant x times sine 2x. Well, again, let's go to look at that double angle formula. And sine 2x, we know, is 2 sine x cos x. And I need to multiply that by secant. And secant is 1 over cos. Now I can put this over 1 if I want, and I'm just going to simply cross off any top with any bottom. And all I'm left with is 2 sine x. Choice 4. Okay, example 4. I see a double angle formula right here for cos 2a, so that means you're going to need to go ahead and look at your double angle formulas for cos 2a, and there's a sine squared here. So you might want to find the one that has sine squared in it already, and that one is 1 minus 2 sine squared a. So I basically replaced this with this. And what do I need to add to it now? I need to add to it sine squared a. So all I'm doing is taking this piece and writing it over here. Let's simplify all of this before we divide by the denominator. So what are my like terms? My like terms are here. I have negative 2 sine squared a plus sine squared a. So if I have negative 2 of something and I add 1 to it, I simply have negative sine squared a. And I'm going to bring down the one that I have from over here. All right, now this whole thing, 1 minus sine squared, I know that that's cosine squared. So I'm going to take cosine squared divided by 1 cosine here. So I'm going to go ahead and finish this over here. So cosine squared a divided by cosine a is simply 1 cosine of a left over. You're going to simply cancel one of these with one of those. All right, last but not least, example number 5. So example number 5, you need to recognize that the numerator is that there's a GCF that you can pull out. So if you divide each piece by 2, you're left with 1 minus sine squared x. And again, 1 minus sine squared we know is cosine squared. So bring down the 2 and write cosine squared. Therefore, that's my numerator. And I'm going to divide that by my denominator. So I have 2 cos squared x divided by cos x. And again, I can cross this top and bottom with one of them, and I'm left with 2 cos x. Final answer. All right, let's jump over to sum and difference formulas now. Next page. The first 3 problems on this page are not that bad at all. All you actually have to do is take your formulas for the sum and difference and work backwards. So I'd like you to find the sum and difference formulas. And for number 1, I want you to find one that says cos cos plus sine sine. So look at all the sum formulas, look at all the difference formulas, and tell me which one it is. Which one it is cosine of a minus b. So we're going to call the first term a, we'll call this b. So it's really the same thing as saying cos 80 minus 70. And again, what's 80 minus 70? 10. So cos 10, choice 1. All right, number 2. Find the formula that has sine cos plus cosine. Okay, the formula that you're going to find is sine a plus b. And we'll say that a is 80 and b is 70. So now we're going to take sine of 80 plus 70. And what's 80 plus 70? 150. So sine of 150, choice 3. Okay, number 3. Look at those formulas again and find where you have cos cos minus sine sine. And cos cos minus sine sine is cosine of a plus b. So again, we'll call a 80, b 20. So cos 80 plus 20. And 80 plus 20 is 100, so cos 100, choice 2. Okay, example number 4. So if we read the problem, bottom line is that they want us to find tan of a plus b. So the first thing that I always do is write down the formula. So go to your reference sheet, tan of a plus b, and let's write that formula down. So tan a plus b is equal to tan a plus tan b over 1 minus tan a times tan b. So we need to find clearly tan a and tan b in order to make this happen. If we look at the given information in the problem, we only have tangent of a. And they give us something about b, but we're going to need to do some solving to find what tangent of b is. So let's draw some pictures. So a tangent of a, let's just draw a picture. It says that they're in quadrant 1. So draw a picture, put a here. Remember, tangent is opposite over adjacent, so TOA. So 2 over 3. So that's a. Let's draw a picture for b. And remember that sine is opposite over hypotenuse, so opposite is 5, and hypotenuse is rad 41. So like we said before, we already have tan of A. We need tan of B. So here's the B. Tan is opposite over adjacent. We don't have the adjacent side, so that we need to find using the Pythagorean theorem. So we have A squared plus B squared equals C squared. So we'll say X squared plus 5 squared equals rad 41 squared. So X squared plus 25 equals 41. Why is it 41? Because when you square a radical, the radical and the square cancel each other out. So you're just going to subtract 25 from both sides, and you're left with x squared equals 16. You take the square root, and you get 4. So, therefore, tangent of B is opposite, which is 5, over adjacent, which is 4. So, let's go ahead and plug into the formula now. So we're going to put equals tan A. What's tan A again? Well, they gave that to us. That was 2/3. Plus tan B, which we just found, was 5 over 4. Now, 1 minus tangent of A, which we just did, was 2/3. Tangent of B, 5/4. So how do I put this in the calculator? Remember, anytime you have a fraction, you're going to do this in 2 steps. So go ahead and put the top in 1 step and get a reduced fraction. So the reduced fraction you should get is 23 over 12. Now, do the bottom. Put the entire bottom in the calculator. Pause the video if you need to. Put the whole bottom in the calculator, get me a reduced fraction. So 1 over 6. Okay, then you're going to put the top in parentheses, the bottom in parentheses. Put it in the calculator, just like that, and get me another answer. And that final answer should be 23 over 2. Finished. Okay, let's try example number 5. So example number 5 is similar to example number 4. Bottom line is that they want us to find what? Cos x minus y. So let's go ahead and use the reference sheet to find our formula for it. So cos x minus y is equal to cos x cos y plus sine x sine y. And again, the formula has a and b, so I'm just changing the a's with x's and the b's with y's. So do we have any information? Well, do we have cos x? No, we have sine x. Do we have cos y? Yes, so we can plug that in right away. So cosine of y is negative 4 over 5. And we have sine of x is negative 8 over 17. So negative 8 over 17. So in order to finish this problem, we need cos x and we need sine of y. So we have to draw some pictures. So what do they tell us about sine of x? X lies in quadrant 3. So let's go ahead, remember the bow tie, draw a picture in quadrant 3. So here's x. Remember, sine is opposite over hypotenuse. So opposite is 8, hypotenuse is 17. Okay, let's go ahead and draw a picture about about y. Y tells you it's in quadrant 2. So here's y, and they tell you that cosine is 4 over 5. So remember, 4 is the adjacent, and the 5 is the hypotenuse. Now we know a Pythagorean triple, so we know that this side is 3. And if you use the Pythagorean theorem for this triangle, you will get that this side here is 15. Now notice how I didn't put in the negatives. The negatives just tell you placement. Remember, AST, that means tangent's positive there. AS means sine is positive there. So now we have the information, we can go ahead and plug in what we know. So cosine of x, so here's x. Cosine is 15 over 17, adjacent over hypotenuse. So 15 over 17. But what do I know about cosine in this quadrant? It's negative, so you need to put a negative there. Okay, now let's jump to sine of y. So we got to look at the y picture. So y is adjacent, which is, no, I'm sorry, it's sine. So opposite, which is 3, over hypotenuse, which is 5. And what do I know about sine in this quadrant? Positive. Therefore, this stays positive. So please put this into the calculator just the way you see it. Parentheses, negative 15 over 17, close parentheses. All of this in the calculator, hit math, enter, enter, and your reduced answer should be 84 over 85. Final answer. All right, let's move on to the next page. Okay, so for this page, you're going to need your double and half angle formulas from your notes. So pause the video, grab those, and then come back. Okay, so we're going to work backwards like we did with the sum and difference formulas. I would like you to find the formula that looks like 1 minus 2 sine squared of an angle. Okay, when you do that, you should see that cos 2a, double angle for cosine, is 1 minus 2 sine squared a. So do you notice how 1 minus 2 sine squared a is in this form? Yes, what's a? 30a. Notice how they take the place of each other. So we're going to put the 30 in for a, and what's 30 times 2? 60. So it's really saying cosine of 60. Choice 2. We worked backwards. Okay, for number 2, same thing. Look at the double angle formulas and half angle formulas and see which one is 2 sine A, cos A. And you'll see that sine of 2A, the formula for that is 2 sine A, cos A. So we have A. Again, A in this case is 30. So we're going to work backwards. So 2 times 30 is 60, but it's sine this time. So sine of 60, choice 3. Okay, let's move on to number 3. Number 3 is saying find sine of theta over 2. That's the same thing as saying sine of a half theta. So you're going to look at your half angle formulas for sine of a half A. A, theta, same thing, it's okay. So the formula that you want to use for this is plus or minus, but it says what's the positive value, so we can ignore the minus. So then 1 minus cosine of theta instead of A over 2. So they give us cosine of theta. Perfect. All we have to do is plug it in. So radical 1 minus 1/8 divided by 2. So now a lot of you are going to have trouble putting this into the calculator. So just listen carefully and do as I say. Type into the calculator 1 minus parentheses 1 divided by 8 close parentheses. Hit enter. Then hit divided by 2. Hit enter. Now change that to a fraction. So hit math, enter, enter. And you will get 7 over 16. So keep the radical. Do 7 over 16. Now what's a radical when you have a fraction? Radical of the top over radical of the bottom. So radical 7 over radical 16. Well, I know that the square root of 16 is 4, and radical 7 I can keep, so choice 2. Okay, let's move on to example number 4. So for example 4, they want the value of sine 2a and cos 2a. So the first thing that I'm going to do is write the formulas down. So sine 2a is 2 sine A, cos A. And cos 2a, well, there's 3 formulas for this one. I mean, the one that I'm going to pick, it could be different than the one that you're going to pick, but you will still get the same answer. So I decided to pick 2 cos squared A minus 1. Okay, so let's give out the information that they have. Let's go back to the given. So the given tells me that sine of A is an angle in quadrant 1, and that sine of A is opposite, rad 5, over hypotenuse, which is 3. So go ahead, let's do the Pythagorean theorem to find the missing side. So what would it be? X squared plus radical 5 squared equals 3 squared. So x squared plus 5 equals 9. So we subtract the 5, take the square root, and you should be getting 2. So now let's plug in what we know. So we have 2 times sine of A, which again was given. So rad 5 over 3. Cosine of A. Well, what do I know about cosine in quadrant 1? It's positive, so I don't have to worry about the negative. And cosine would be adjacent over hypotenuse. So that would be 2 over 3. Now the directions say to find in simplest form. So we can't put the radical in the calculator and expect to get a radical out. So we actually have to simplify this by hand. So this 2 over here can be written as 2 over 1. And how do we multiply fractions? Tops with tops, bottoms with bottoms. So the 2 and the 2 can multiply, which would give me 4. And then we tack on the radical 5. So 4 radical 5 over, what's 3 times 3? 9. That would be your simplified form. Okay, cos 2a is equal to 2 cos squared a minus 1. So 2 times cosine of a squared minus 1. What's cosine of a? We said before that that was 2 over 3. Now this expression doesn't have a radical in it, so we can put this in the calculator. So go ahead, type this in just the way you see it, and hit math enter enter to get yourself a reduced fraction. And you should get negative 1 over 9. Final answer. Okay, last problem. Number 5. It says, if cos of a is equal to 4 over 5, find the positive value of tan a half a. So the first thing that we need to do is write down the formula. So tan a half a is equal to 1 minus cosine of a over 1 plus cosine of a. Now there's no need for a picture in this problem because they gave you cosine of a. So they tell you that cosine of a is 4 over 5. So 1 minus 4 over 5, and then 1 plus 4 over 5. So again, just like everything, weight the radical till the last step and put the top in just the way you see it. 1 minus parentheses 4 over 5, close parentheses. Hit enter and get me a reduced fraction. You should get 1/5. Do the bottom now. 1 plus parentheses 4 over 5, close parentheses, get me a fraction. You should get 9 over 5. Now, in the calculator without the radical, do parentheses 1/5, close parentheses, divided by parentheses 9/5. Hit enter, get me a fraction. That fraction should be 1 over 9. Now we're going to take the square root of that. So square root of the top over square root of the bottom. So final answer, 1 over 3. Okay, next page. Okay, the answers to these problems are on the e-board. I'm not going to go through each one verbally here, but all my work is online. They are on the e-board for Friday the 27th. All right, good luck.